Welcome to the Making of Me podcast, where we unpack the real stories, struggle, and system that shape who we are. Today, we are joined by Adam Koga, a writer, system analyst, and author of the dictionaries and the Fuck Up Almanac series, who turned failures into lessons for navigating life and business and technology. It's really a pleasure to have you on the show, Adam.
Happy to be here. Hello.
Yeah, thank you. So, Adam, what challenge shaped you into who you are today?
Oh, the list would be long, but most recently, bad breakup, I'd say, because that's how my writing career started. So, yay.
So, Adam, you actually spent 20 years in IT. What is the single biggest misconception people have about technology and system?
Biggest misconception would be that the IT industry is about technology, and for people that are introverts, that's hands down the biggest misconception because that's one of the most teamwork professions I can think of actually. Because no system in the level of complexity that we are talking right nowadays can be built by a single person. So it is all the time about coordination, cooperation, working together. That's something you cannot avoid. And also, that's a source of most problems and so-called technical issues that we encounter.
Amazing. Thank you, Adam. So, many digital transformation fail. Why do you think it's really the technology that is at fault?
Because technology is fully deterministic and can be understood or predicted. The fun part is when the technology meets the way we as a humanity as people think and how often do we make some mistakes. So understanding the really what we need versus what we describe. So basically communication factors, station, those are the source of the problems. And sometimes focusing on not necessarily the best value, the values that would be most beneficial, but maybe on the values that are most flashy, let's call it.
Yeah, amazing. Thanks for sharing. So, how does corporate structures influence software architectures, and what does Coway law really teach us?
So Conway Laws says basically that every single architecture, I won't quote it right now, but in IT it would mean basically that every single software architecture is reflecting the organization structure, will reflect the organization structure that created this software. So basically suddenly that you have a team and this somebody needs to be promoted, so he needs to get a team, so the organization would promote a person and find a new and create a team that person would manage, but this team needs something to do, so it gets some subset of responsibilities, and this rinse and repeat enough times, and suddenly from a neat architecture of the software you have a sprawling labyrinth of interdependencies, and basically it is quite often reflection of how the organization is organized. And more importantly, since the software evolves over decades nowadays, it also has, almost like in geology, you have layers of past decisions upon other decisions, and here we are. So understanding this nuance is this aspect of communication that we quite often forget about.
Yeah, amazing. Thanks for actually sharing that. I think it just speak a whole lot of volume, being that there's a whole lot to learn from this, and it's easy to just pick what is going on as IT problem when we don't understand people, and when we could actually just easily push the blame on any persons. And the fact that you just made reference of that, I think speak volume. So you actually miss humor and and sarcasms with serious failures analysis. Why does this combination work so well?
Well, I'm quite sarcastic person by nature, so it always works everywhere for me. But more importantly, the humor lowers the defense. So sometimes the bad message or straightforward criticism could trigger self-defense mechanism, and as a result, it wouldn't be hit the right person. So what I did with especially IT dictionary was full on satire, but every friend or colleague I spoke with recognizes the patterns quite quickly. That's one thing. And for the serious analysis that I went for in the Fuck Up Almanac, the role of the humor is much more mundane, let's say. It's just to make it digestible. I didn't want to write another academic essay or textbook that nobody would read without the hectoliters of coffee. I wanted to make it approachable for everybody, for people who are not necessarily deep in technology to understand what's going on. So a little bit of humor and, let's say, pub talk narration helps. That's pretty much what the much better people, writers than me, do. Like, for instance, Monroe. There is also a couple authors that I can think of, but right now all of them are Polish, so I won't tell the names. But basically to make it approachable. And analysis, and serious analysis, because, well, that's where the interesting part about the modern world works, lies. It's not even about the technology, it's about the understanding systems. And what I try to show in my work is that the scenography changes, but the mechanisms are the same. Quite often I use weird analogies or show that the same mistake happening in IT can happen in, I don't know, civil engineering, bridge construction. This will be focus on my third volume of the Fuck Up Almanac. So understanding the mechanics and systems helps be better at your work, no matter if it's engineering, it is medicine, politics, economy, mechanism, repeat.
Yeah, amazing. Understanding your work actually helped to reduce a whole lot of stuff from various ends. So cognitive bias will keep smart people repeating mistake. Which bias frustrates you the most in professional environments?
Just one? That's difficult because I actually plan to write an entire book about those. But one bias that I would say the most problematic, I would have to say Dunning-Kruger effect. Maybe it's not the most striking, but the most dangerous one. Basically, it was debunked, by the way, but the term stays. But basically, it says that people with low level of knowledge, of the discipline knowledge, tend to overestimate their level of understanding, while the people with the high level of understanding or specialty in the discipline tend to underestimate it.
Yes.
So, for instance, if you ask a medical doctor with PhD and 20 years of experience about something related to medicine, you will get the answer, it depends, I'm not sure, I would need to check. If you ask somebody who watched two videos on TikTok, probably you will hear that it's easy and they know the answer. This is real plug nowadays because this confidence is perceived as better. That sprouts everywhere, from day-to-day interaction, politics, which I don't like to talk about, organization culture, even the hype with AI is affected by this specific bias.
Wow. Wow. These biases, I think it's the fact that you can just easily name them, and the fact that it's heavily relied on system. So simplifying system is often harder than building complex one. Why is that, and how do you get better at it?
So it is, well, first let me ask you a question. Are we talking about building simpler systems or explaining simpler systems? Both are more difficult than complex ones, but which should I answer first?
The building.
So building simple system is more difficult because this requires the architect to fully understand and grasp the problem. Quite often, most of the complexity comes from, okay, let's start building, and then start finding the edge cases that we need to add some extra conditions, workarounds, and stuff. And a lot of complexity is just quite often the result of not understanding the original problem that was being solved. So it kinda releases the necessity to, or possibility to build complex system reduces the need for initial upfront investment into understanding what we are working on actually. And the world is complex place.
Yeah, yeah. I think there's a whole lot to actually make profession of being that starting out, especially more like our civilization, just we make profession of it can be more like a complex system, despite it's a simple system from the head start, but being that they take a whole lot when it comes to the learning and everything, putting it in a plain test, I think there's a whole lot to just still look at in respect of that. So what can developer learn from this high stake industry, like aviation and nuclear power?
Well, once you understand that everything is the world likes to rhyme itself, we can learn a lot. But a couple simple examples. What software engineers can learn from aviation is what the entire industry learned was a postmortem process, which is core concept among of the book. So basically, learning from the incident that happened, how to make sure that the incident does not repeat again. The entire process is literally taken one-to-one from aviation. The process itself is actually older. It comes from medicine, but in the formalized engineering way. That was the aviation. One famous example about around that would be a question why airplanes have round windows. That's not an aesthetic choice. This is a result of actual accidents in early age of jet aviation in 50s when the airplanes had rectangular windows and they were falling apart. About nuclear world, let's say, industry, one simple example I can think of is Fukushima. This is an example that I mentioned in the book. Well, it was a disaster. It was the huge incident. It was a disaster and caused a lot of casualties. So that's not something to joke about. But it's also a good lesson about redundancy, preparing entire building or system in this case. Sorry for overusing this word to inevitable problem. Designers in Fukushima made a couple mistakes or not that good assumptions. Like for instance, they did protect against the big wave from the ocean, but they took the historical data, not accounting for what could happen when the tsunami struck. It was just taller than any wave breakers that were built around. Another example was that the Fukushima power plant had 13 power generators, and I think 7 of them were at the same height below the water level after the wave arrived. So they were immediately shut down. I don't remember right now the other ones, but out of 13, 12 were disabled. That was the source of the disaster of overheating the reactors and stuff. The one power generator that survived was using slightly different technology. It wasn't, I think it was diesel, but I'm not sure. And it was much higher, located much higher. And this generator provided enough electricity to do the proper cooling down and shutting off procedure of two of the cores. So as far as it was a big disaster, it could have been much worse if not this one single power generator. Well, it is, even though in IT the stakes are not as high, it is a very valuable lesson about the designing reliable systems. And there is a common mode mistake where we make systems or components redundant, but just copy them one-to-one. Which means in turn that if we make identical copies that have some problems, they will just appear multiple times. That's pretty much what happened with Ariane 5 space rocket in European space rocket that was launched in 1996 and turned into fireworks 5 minutes after start.
Yeah, wow, amazing. It just speaks volumes that a whole lot actually we learn from the system, even in vision and others, in comparison of everything we actually want to face. And that's a really whole lot. So what is next for you as a writer and system thinker? Where do you want to take your work from here?
That's a long story because it's not something that I planned very deep thoroughly. It's more evolving as I write and come up with ideas. For instance, the series that I'm working on, Fuck Up Almanac, started as an idea for a couple promotional posts. And when I started doing research, I realized it's more than couple posts. And then I continued doing research and I ended up with a plan for 4-volume books. Series, and well, first volume will be released very shortly. As we're recording it, it will be in about a month, and it is 500 pages. Second, third, and fourth volume won't be shorter, so it is enough work for this year for me. But I already have ideas for the next one. Would be dropping the engineering world more into, let's call it psychological. I'm not a psychiatrist or psychologist. I'm not in this field, but to look into those mental patterns, mental traps, cognitive biases. So I mentioned already Dunning-Kruger effect, but the list is very long. There's a perverse incentive, there are sticking to the wrong model, there's mixing some terms like correlation versus causation. And sorry for using jargon, I really don't like it. But that's something that I'd like to describe or say what are my thoughts about why we keep repeating mistakes and just catalog certain thinking patterns that we tend to repeat. Then I'd like to go into teaching the something very close to my heart, which is systemic thinking. This is, and skipping all the mathematical and scientific jargon that I really, well, I like, but don't, I like understanding and learning about, but not necessarily using in those language complex stuff. It's more about the art of spotting similarities. It's very easy to find differences, but the real value is in finding the similarities and how something can be translated. This helps to build models, but also this helps moving the knowledge between industries and just be better at your job just from learning one thing and applying it to totally different area once you see those similarities. There are good books about that, but for my taste, they are quite difficult to digest. I'd like to make it a little bit more accessible and attractive. It's an ambitious goal, but I hope I will manage.
Yeah, amazing. Thank you so much, Adam. So, from our audience who want to connect with you, who want to learn from you, and even get your book, how can they reach out and where is the best platform to do this?
I'm not sure if it's the best platform, but for sure it's a central point. Just go to my official website, adamkorga.com. You'll find my blog, you'll find possibility to sign up for the newsletter, you'll have information about my books, you'll find bibliographies to books that I publish or I'm close to publication. You'll have links to my social media, most importantly LinkedIn. So basically, instead of listing everything, just visit my website and you'll find everything there.
Thank you so much, Adam. Thank you for sharing your insights, your wit, and your system perspective with us today. This conversation has, yeah, it has really been amazing just listening to you talking about system. And for my audience, if this conversation resonates with you, you want to hear more from Adam, you could actually visit his website at adamkorga. It's going to be on the show notes for you to easily reach out. This has been the Making of Me podcast, where stories, real system, real learning actually is being talked about. Until next time, yeah, once again, it's really a pleasure having you on the show, Adam.
Thanks you for having me.